Welcome to the Hararian Network, where we're connecting people through networking. And the last video I put out, which has been quite a while, I know, and that video had to do with doing how to do labs, based on a narrative, a story, right? And we even got introduced by setting up something very basic like two computers communicating with each other within a company, right? This was the scenario. And we're going to continue that story based on the scenario. And let's get right into it right now. So, like we mentioned earlier, that was the case right here, right? So these two computers. Now, let's say that we end up getting more computers. The manager said we got about 8 more computers, so a total of 10, right? And let's just make sure we have all of them here. Alright, so now we have these computers, but we cannot just connect them like this, right? Because only two computers will communicate with each other. And the thing is that we want to make sure that each and every of these computers can all speak with one another. So that means that we need some way to connect all of them together. And how are we going to do that, right? Well, the thing is, the way we're going to do that, we're going to need some sort of a device, a networking device that can help do that. And we're going to make a network with all these computers together. And they're going to belong on the same network too, just like how these two computers belong on the same network. And in that case, what we're going to do is we're going to remove the cable, alright? So that's first and foremost. Let's remove this cable right here. We don't need this. And now, on the other hand, we're going to need a device to connect them like I mentioned, right? So that device is known as a switch. So the switch is right here, right? And in this case, we're going to start with something like a basic 2960 switch from Cisco, right? So we're going to need this switch here, and we're going to connect all these computers together. And the type of cable we're going to need in this case is a straight through cable. And we've explained earlier from the last video about the straight through and the crossover cable. So let's get a straight through here. Let's connect it to the first port, right? And let's connect that right here. And it's going to take long, like maybe about 30 to 50 seconds or so to come up right here for this port. And the reason as to that, it has to do with a protocol known as spanning tree protocol, because it wants to make sure it prevents any loops between switches. And we're going to do something about this later on. But for now, that's something to keep in mind. So it takes about 30 to 50 seconds to change to different states, from blocking, listening, to make sure it knows the MAC addresses, because switches understand MAC addresses, by the way. They don't understand IP. And then learning it, and then after that, it's going to forward. See, now it's in the forwarding state, everything is good. So we're going to do the same for all these other computers as well too. So let's just do that. And kind of bring them over here just to make it more easier and neat and organized. So let's just make sure everything is good from here. And then there. So that's about all of them connected now, right? Cool. 3 of them are still taking time to come up, going through the spanning tree states to make sure it becomes in a forwarding state, right? But later on throughout this process, when we have other switches and other computers connected, we're going to set up the switch in a way that it does not have to wait for these 30 to 50 seconds. And now that we're talking about this, I believe it was this computer that has an IP address, right? And we've talked about static or DHCP as well too, right? In this case, we see this one has one, and then this one also has one too. Now we're going to have to set up all of these other 8 computers with IP address and the subnet mask as well too, to make sure they belong on the same network so they can communicate with each other. We're going to test a different 2. Oh, we used one that's already in use, so my mistake. We're going to have to make sure we use another one. Now it should be good. Yes. Alright. And then here, do the same thing. And let's just test this out. So we're going to see if this computer is going to be able to communicate with this computer. Since these two are new computers, we already tested these two out. Let's just make it a little different. And let's see what happens. Alright, so this was .4, right? .5, pardon me. This was .4. So let's test by pinging. So now we understand what ping is too as well from the last video, right? And 192.168.2.5. And let's see what happens. Okay. It's able to reach there. And by the way, what is going to happen now is on each of these ports, so port FA03 and FA04, it's going to learn these MAC addresses of the devices for the switch, since switches do not understand IP addresses. And by default, as you can see, the switch connected and everything works. So that's something else to keep in mind. And in order to see that information about the MAC address, we do the command show MAC address table. And we're able to see, so FA04, this is the MAC address, so that's learned right here. So let's just make sure about that. We can check that out by going to ipconfig/all. To see the configuration, it'll show also the MAC address. So let's see, physical address is the MAC address, by the way, 004.9ABC.DCE1. So if we check the switch, and let's say that we went into the switch, we consoled into it to get into it and have access, right? So if we see FA04, we can see right here, DCE1, FA04. Same MAC address as that computer, so it learned it. And then for number 3, 41A9 is the last part, right? So let's go over here too, just to even double check and make sure that if it learned the right device. And 41A9 right here, we've seen the end, so it did. So this is what happens throughout this process of this computer communicating with this computer. The switches learn the MAC address of each computer on each port, and what happens is that at first, this computer is going to send out a broadcast message through the switch. That means it's going to give it out to every single computer except for itself. But all these other computers here, they're not going to accept it. This computer will, because that's who we're trying to reach to. And then from there, it's going to record the MAC address in that table that I showed you. And basically throughout that process, that is known as ARP, which is going to be making sure that the IP address of the computer, they're going to map it to the MAC address of that computer. And based on that, that's how it's going to get the information. And if we want to see the ARP table, the command is show ARP on the switch. But right now, nothing is up. But basically, that's what's going to happen throughout this process. All right. And now, if we continue doing this, just going to copy this because they're on the same network. And now all of them have IP addresses, so they're all going to be able to communicate with one another. Let's test, let's say, number 4 and number 5, right? So this one was .6 we set up, and this one we did as .7, right? So let's do that. 192.168.2.7, and here we go. They're able to communicate with each other. And we could even check another way of a simulation here, just to see what happens based on the point I mentioned about the broadcast message, and then from there the device that's the destination device will accept the data, the other ones won't, and then they're gonna have one-to-one communication, known as a unicast, by the way, message. So let's just test 6 and 7, okay? So 6 was .8 if I'm not mistaken, and 7's .9. So let's ping .9, 192.168.2.9. And now let's just see what happens here. So it's going to go to the switch. It's going to send to everyone. And then once it finds it out, you see this one gets the message, the other ones don't. And then it's going to let the switch know. And then from there, it comes back to the one I just started with, the ping, the source. So that's basically it. And just to make sure, let's see the MAC address of each of these, right? So 69A6, and this is on port 07. All right. And let's check this one too. The last, what's it called? The last 4 digits here is 85C8, right? So that's going to be 85C8, and this one was 69A6, right? So if we do show MAC address table, you can do the up tab to find out your recent configurations or commands that you typed out, pardon me, and then you can enter and see. So 69A6 was 07, and then right here, this one was FA08. So if we check that one, 85C8, and we see here, that was the MAC address, same MAC address. So the switch learned it. And this only stays in the table for about 5 minutes. So that means that if there is no activity within 5 minutes of time between these computers, it's going to remove the information in its MAC address table, but then when it communicates again, it'll come back again. Something to keep in mind as well too. And honestly, that is all for this video for today. And the whole point of this breakdown was to find a way for all these computers to be a part of the same network, so they all could be able to communicate with each other, and they're all able to even get a message. And we've seen the process of what happens. The first message goes to every single device, but the only one that's going to accept it is the actual destination, and then from there it's just going to be one-to-one communication between the source and destination device, in this case the computers, right? And that's all I wanted to tell you for today and for today's video, and we're going to continue more throughout this situation and scenario later on. And until next time, take care.